So hello friend, welcome to my channel. So today I am going to discuss about the revision class organic reaction intermediate. From these points also there are a lot of question has came in exam. So this is a revision class. So if you have not subscribed my channel, so please subscribe the channel and click the bell icon and share with your friends. Okay, now we start. Earlier in my lectures I told you some topics, so in this lecture I will cover all points. So points, first is basically reaction intermediates. Inside this I will discuss stability of this carbocation, carbanion, free radical, carbenes, benzenes and nitrenes. Okay, so start reaction intermediate. So what is reaction intermediate? Okay, so what is reaction intermediate? So it is basically when a homolytic or heterolytic bonds fission, then the formation of short-lived species called the reaction intermediate. When homolytic or heterolytic bond fission happen, then form the short-lived species, which is known the reaction intermediate. Okay, so these short-lived species or intermediate are very reactive and quickly convert to the more stable molecule. So it is very reactive and quickly convert to the more stable molecules. Okay, so you all are already familiar with these points. Okay, so there are four. Actually I choose intermediate. First, carbocations. Second, anion, carbanion. Third, free radical. Fourth, carbene. Okay, fourth is carbene. So Now we'll discuss one by one. First I will discuss carbocation. I am not here discuss about the generation and reaction of these species. Only I will discuss the stability and structures of these species. Okay, if you are interested, you can read more deeply from any books. Okay, so I will give only in stability and structures knowledge. Okay, so this carbocation is actually positive charge species. Okay, and this carbocation intermediate is in a large numbers of organic reaction. Actually we have seen in all organic reaction this carbocation intermediate, because of it has 6 electrons, because it has 6 electrons in valence end and easily converted to in complete octet. Okay, that's why this carbocation is form every organic reaction. So what is the structures? Structure like this. You have C, you have alkyl and alkyl group, and this p orbital. Okay, this is vacant p orbital. Okay, so hybridization is expected. So now we will discuss the stability. So stability is basically, it depends on the how the electron means donating group stabilize this cations. So that is known as stability. So mostly the which I have read, cycloheptatine cation is highly stable and most lesser stable is methyl carbocation. Okay, so generally you can write as a notes cycloheptatine is highly stable and most lower methyl. Okay, so you should remember about this. So if we write the order, decreasing order of this carbocation stability, heptatine. So like this, okay, like this, like this, like this. So you have 7 carbon, 1 2 3 4 5 7. Okay, so you have plus teacher. So this is heptatine, okay, which is more stable than this tertiary carbocation, which attached to the benzene. Here also benzene, okay, here also benzene, which is greater than secondary of this species, okay, which is greater than this tertiary of this species, because here 3 benzene rings are neutralize this cation through delocalization, okay, that's why this is more stable. But in secondary only 2 benzene ring only delocalize to stabilize the carbocation, that's why tertiary carbocation is more stable than secondary. Similarly, this is greater than this, like that. There are several, you can this, okay, which is greater than this, and this is greater than methyl. So methyl is the most lowest stable species, okay. So if we write another other in the form of carbocation, so tertiary carbocation is more stable than secondary than primary, okay. So now we move to second discuss carboanion. So what is carbanion? So carbanion is basically when all carbon atom has negative charge, means it is basically denoted by negative charge. When a carbon atom is negative charge, like if you see methyl, this this okay, and this. So all these are the carbanion. And if you see structure, so structure of this species is like this. This is basically the electron, sorry, this is the R. So this is basically the here having 1 2 3 and 5. So only one electron is needed for complete the octet. So how to define stability here? stability. So stability is when an electron withdrawing group or atom stabilize the carbanion by delocalization is negative charge. So any electron withdrawing group or atom stabilize these carbocation by delocalization. Okay, so here your methyl will be higher stable than 1 degree, then second, then third degree. Just reverse of this carbocation, because here any electron withdrawing group stabilize this carbanion. Okay, that's why the stability just reverse of the cations. Okay, so now discuss about the free radicals. So 3 free radical. So free radicals when a chemical species having one or more unpaired electron, one or more unpaired electrons is known the free radical. If any species, a chemical species having one or more unpaired electron, that is called the free radicals. Okay, as I told earlier, homolytic and homolytic bond fusion leads to the formation of free radical. Okay. So here only the if you break the homolytically any bonds, then free radical will form. Okay, so it is basically the odd electron molecules, odd electron molecules are species. Okay, so if we say this methyl 1 electron and this CH2H5, you can see C6H5H. Okay, like etc. There are several species. If we see structures, so structure is so this was only one electrons here, and this angle is 120 degree. This is sp2 average. Okay, so this is the structure. Now we'll discuss stability. So stability of this free radical such as methyls and butyl radical are highly reactive species. So if you see methyl or butyls, which is highly reactive, butyl, these species are highly reactive. Okay, because when two free radical species of this methyl react, form dimer. Okay, this. Similarly, we can take another also other examples. So for this stability adder, I will tell you. First I clean this and I will tell you. Okay, now we'll discuss the free radical stability. Okay, so free radical stability is basically explained through it is explained through hyperconjugation. Okay, and if you see stability adder, so here tertiary butyl will be higher stability. This will be higher stable than secondary, then this primary, then this metal. Okay, so if you see here also stability under this in terms of benzene, so this tertiary benzenes, this will be high stable than secondary, then primary, then this. Okay, now we will discuss the fourth, carbions. So what is carbions? Carbions is basically neutral divalent and highly reactive. Species Alice reactive carbon intermediate were containing two single bonds and two non-bonding electrons like this. So here two single bonds and two non-bonding electrons, these non-bonding electrons. Okay, so if you see structure of this carbon, so structure look like this. So this is pair electron, sp2 orbital. This is basically sp2 singlet carbon. Another one, if both electron is separately filled, then it will be the like this. This is sp2 triplet carbon. Okay, so now if we see the stability of this carbon, so stability is generally triplet carbon is stability is higher than singlet, because triplet carbons 2 electrons in different orbitals. There is a less electronic repulsion than the when both are in the same orbital. That's why triplet carbons is more stable than singlet carbon. Okay, so this carbons is actually the electron deficient intermediate, because it has only 6 electrons in its valence shell. Okay, so only 6 electrons in valence shell. That's why it is electron deficient. Now we talk about Nitrenes 5. So nitrene, this is also the neutral and monovalent species nitrogen, and this is analog of analogous carbon. So it means that here the some features you will find like of carbons, so it is the analog of carbons. So if you see nitrogen structure, so here this is nitrogen, and if you C6, you write C6H5, and this is phenyl nitrene, and you can write alkyl nitrene also. This is alkyl nitrene. So if you see structures, so structure is, it is similar to carbons like structure. Okay, so here this 2 electron is lone pair electron, and these 2 electrons, it will be either singlet, means singlet, and this will either this will be singlet when both are in paired. Okay, and when will be triplet, and both or will be a unpaired. Okay, then this will be triplet. So if we write X structures, so this is unpaired. Okay, so this is triplet nitrene. So this is triplet nitrene. If you write then this, so your one electron unpaired, like this is p orbital, and here your pair electrons. Okay, so sp2 orbital. So this is for triplet nitrene. So for now, if both electron is paired, then it will be the singlet is carbene. So singlet, I mean nitrene. So this is singlet nitrene. If you talk about stability, so stability is basically when when we see the comparison of this singlet and triplet carbenes of these nitranes, which is much larger than carbenes because of the electronegativity, because N is more electronegative than carbon. So the energy difference between singlet and triplet of these nitranes is much larger than carbenes. Okay, so basically the here your triplet carbenes is more stable than singlet carbenes. Now last thing, benzenes or aryls. So this is also, it is a neutral, and it is a neutral reaction intermediate. Okay, and which is derived from the benzene ring by removing the two ortho substituent. One is electrophile, another is nucleophile. So basically this is your benzene. Okay, this is 1,2 dihedra dihedra benzene or benzene. This is, if you see structure, so structure look like this. Okay, this is abnormal, pi 1, which is very weak because of less efficient overlapping, and hence it is, this benzene is very unstable and highly reactive. That's why it become highly unstable and very reactive. So this is the some importance of this reaction intermediates of carbene, carbocations, carbanions, free radicals, nitrates and benzenes. So hope guys you have understood what I have taught you. Okay, so okay, thank you, bye bye, good night.